Plant Miller is a coal-fueled power plant located in Quinton, Alabama, on the Locust Fork branch of the Black Warrior River, about 25 miles northwest of Birmingham. The plant provides over 20% of Alabama Power Company's generating capacity and is the largest generating facility in the state, with a peaking capacity of over 2.9 million kilowatts, or 2,900 megawatts of electricity that can serve over 822,000 homes. Named for Mr. James H. Miller, a former president of Georgia Power Company and senior vice president of Alabama Power, Plant Miller first provided electricity to our customers in 1978, with the most recent unit commissioned in 1991, making Plant Miller the newest coal-fueled power plant in Alabama. At Plant Miller, we use coal, air, and water in an energy conversion process that allows us to deliver electrical power to homes and businesses. Using coal as a fuel source, we generate steam in our boilers. That steam will be used to turn a turbine that ultimately allows us to generate electricity. Of course, there's a lot more to it than that, so let's take a look at how the process works. Our process uses Powder River Basin coal from Wyoming, a sub-bituminous type coal, as a fuel source. When the coal arrives at our plant by train, we use a trencher and a series of long conveyors to stack coal in our yard, move it to storage silos, or send it directly to the plant. We try to keep a 37-day supply of coal, about 1.4 million tons, on the pile in our coal yard, and up to 40,000 tons in silos. Since we burn as much as 38,000 tons of coal in a 24-hour period, we need to ensure we have a substantial amount on hand. Coal moves into the plant on a conveyor and is stored in a series of silos, each one leading to a feeder, pulverizer, and ultimately to the boiler. At Plant Miller, we have 4 generating units, and each unit has 7 silos feeding into one single boiler. The coal within each silo falls into a feeder, which measures and controls the flow of coal into a pulverizer. Inside the pulverizer, coal falls onto a large rotating bowl, where it is continuously crushed by 3 large grinding wheels until it becomes the consistency of baby powder. Once the coal is a fine powder, it falls off the grinding bowl and is carried by warm primary air, maintained at 140 degrees Fahrenheit inside the pulverizer, to the boiler through 8 burner lines. When the particles of coal reach the burners, they are mixed with secondary air that has been preheated to over 500 degrees to support complete combustion inside the boiler. The combustion of the coal converts its chemical energy into thermal energy, creating a temperature inside the boiler of over 2200 degrees. That's enough to heat the water in the series of boiler tubes to create steam, which moves onto the turbine to power the next step in our process. Superheated steam from the boiler, which is approximately 2400 psi and 1000 degrees, travels to the high-pressure section of the turbine, where it creates the force that turns the turbine shaft. This process causes the steam to lose temperature and pressure, so it must be sent back to the boiler to be reheated to 1000 degrees. After reheating, the steam returns to the intermediate turbine and continues through the crossover into the low-pressure turbines. The force of the steam turns the turbine shaft, which turns the generator rotor at 3600 revolutions per minute. This rotation, along with the induced current on the rotor inside the generator, produces voltage, completing the process of generating electricity. The generator output is 24,000 volts, which is stepped up to as much as 500,000 volts for transmission. Plant Miller uses a closed-loop circulating water system that allows water to be reused over and over. One way we use water is in the condenser, where steam enters from the turbine and condenses back into water as it passes over tubes filled with cool circulating water, which is chlorinated river water from nearby Mulberry Fork of the Warrior River. The condensed water moves into the hot well, where it re-enters the system to be reheated, turned back into steam, and continue its use throughout the plant. Let's take a closer look at the circulating water the plant uses, starting at the cooling tower. Cool water is pumped from the cooling tower basin through large pipes to the condenser to absorb most of the heat from the turbine exhaust steam, leaving us with warmer water that must be cooled. So, the warmer water is circulated back to the cooling tower, where it enters through riser lines to the top of the cooling tower film. As the water cascades down the cooling tower fill material, it's air-cooled, allowing the heat to escape up through the natural draft cooling tower. The cooled water is collected in the cooling tower basin to be recirculated back to the plant to condense more turbine steam exhaust. Once combustion is complete, the heavier particles of ash, called bottom ash, fall into the bottom of the boiler. There, the bottom ash is crushed using clinker grinders, mixed with water and sluiced to the hydro bins, where the water is decanted and ash collected in dump trucks and either sold or moved to on-site storage. While the heavier particles of ash fall to the bottom of the boiler, the hot flue gas containing finer particles of fly ash naturally flows up to the top of the boiler and around, down, and out through the backpass section. The last section of the boiler is the economizer. Because of the shape and the flue gas flow path, some of the fly ash falls out here into hoppers. This economizer ash is pulled by vacuum, mixed and sluiced with water to the ash booster station, where it is moved to on-site storage. Flue gas, a byproduct of combustion, exits the boiler and enters the selective catalytic reducer, or SCR. While entering the SCR, ammonia is injected into the flue gas stream, where it reacts with several catalyst layers to reduce the nitrogen oxide compounds. The flue gas then passes across the air heater, where over 400 degrees of temperature are transferred from the exiting flue gas to preheat the primary and secondary air entering the plant. Next, the flue gas passes through the precipitators, where a negative charge is induced onto the fine particles of ash contained in the flue gas. That ash is then collected with an opposing charged collecting plate. These plates are then shaken by vibrating wrappers, causing the ash to fall off into hoppers at the bottom of the precipitator. The ash is then pulled with a vacuum to a collection facility for sale or storage. The flue gas then passes through the induced draft fans and to the scrubber, where booster fans pull the flue gas from the plant and push it through the scrubber absorber. In the absorber, flue gas mixes with water and limestone. The limestone reacts with and removes about 98% of sulfur dioxide, creating the byproduct of gypsum. The wet flue gas exits out the top of the absorber through to the wet stack, and a gypsum slurry stream is pulled from the bottom of the absorber and sent through a dewatering facility. Inside the dewatering facility, most of the moisture is removed from the gypsum so it can be sold for use in wallboard. When the power leaves the plant, we increase or step up the voltage for transmission purposes to as much as 500,000 volts to help minimize losses from the transmission of power. Our transmission group is responsible for the large transmission lines, towers, and substations that handle the large voltage transfer of power over long distances. Our distribution group interacts with our customers more directly and handles delivery of the power in lower voltages stepped down in substations and delivered to industrial, commercial, and residential customers in various voltages to suit their needs. It is our responsibility to provide our customers with reliable, affordable, and clean energy for their needs, and we take that very seriously. We hope you enjoyed this virtual tour of Plant Miller.